Hello to all of you. Thank you very much for coming, and to the organizers, thank you very much for inviting me. And to British Rail, or whichever company that was, thank you for getting me down here on time from Sheffield this morning. Lovely to have you here. I want to get started right away. My name is Friedman. I'm a consultant with MapR Technologies. They're headquartered in San Jose, but located around the world. And I also write various books for O'Reilly Media. I'm a committer for the Apache Drill and Apache Mahout open source projects, and this is contact information I'll repeat at the end. Now, I think all of you are here today. I believe the theme for this conference is Big Data Revolution, and indeed there has been a revolution. I think people now are sufficiently used to the concept of big data, that's not the new thing. The new thing is we've got it, what do we do with it? And people are looking for the best practices, the best approaches, the best technologies to build projects, to get value and quickly value, time to value out of the data that they're collecting. But within this revolution, there's a new revolution happening, and that's what I want to talk about today. And that's the revolution towards streaming data. And people are moving quickly towards streaming data, for a little bit of a pun there. A lot more people are collecting it than have before, and they're looking for new ways to use it, putting it to use in some very creative ways. So we'll start with the basic question of why stream? And the best way I can explain this is that our best understanding comes when conclusions fit evidence. And that works best when the evidence and the analysis that we do are a good fit to the way life happens. And life happens as a series of events, or to put it in short, life doesn't really happen in batches. And this is one reason that this move towards streaming is really gaining a lot of momentum, a lot of popularity. So starting with a very familiar example, if you're driving to work, I live and work in the Bay Area in California. It's a lovely place. It has way too many cars and too many people trying to go to the same places. If you use one of these navigation apps, such as Waze, you're taking advantage of one of the real values overall in big data, and that is that data in the aggregate can have a great deal more value than data in little bitty pieces. As you put it together, this data streaming in from all these different motorists, you're able to understand what's happening with the traffic conditions in the moment. But the key point here also is that while it might be interesting to know that there was a traffic accident and a slowdown last Monday, that's a lot more interesting if you know about it on the day when you're trying to drive to work and you can find another route. So a second lesson here is that there is a time value to data. Being able to get insights in the moment, again, is one of the things that's driving people toward the use of streaming data, toward doing real-time processing, real-time analyses. But keep in mind, that's only one of the reasons to move to this style of work. Now, some of the more exciting ways that people turn toward using streaming data, and certainly has had a lot of publicity, is through the use of sensor data. A lot's being said and done about IoT, or Internet of Things data. I use this example that manufacturers are now making so-called smart parts. I think it's actually the manufacturers who are smart. They're smart enough to put sensors in their parts that go into things like this turbine that might be in a jet engine or a wind farm. And so these sensors are able to collect ongoing data about how that piece of equipment is functioning in situ, actually in the world, in the real world over time. And that's useful information going back to the person operating the equipment, such as what's happening in a jet plane while it's traveling. But that information also now can go back to the manufacturer, and that helps inform how well that equipment functions, whether they need to make changes in design in the future. And it turns out it actually, in many cases, opens a new line of business, because the data itself becomes a product. A lot of people would like access to that data to analyze it in various ways. Yesterday at the University of Sheffield, I was taking another visit, going back to visit their Advanced Manufacturing Research Center, which is a partnership between the university, where they use the research knowledge from various departments in the university to work in partnership with a variety of companies. They've built this Factory 2050, which is a completely reconfigurable factory. They work with a range of different companies to be able to bring this knowledge to practical solutions to real-world problems problems in manufacturing, to have this flexibility to quickly respond to changes as data comes in, new ideas come in, to be able to redesign what's happening, to even reconfigure the manufacturing floor. Some of the tools are actually smart tools that are being used in manufacturing. And so in this whole manufacturing scheme, from literally the process of building part of whatever you're building, what's gone into design, feedback from the field, all of it goes together, and this is a huge change. And a great deal of this is making use of streaming data. But it isn't just that in-the-moment insight. It isn't just the need for real-time analysis that's the only reason that people get value out of looking at streaming data. I'm going to hop back and forth from one use case to another because these techniques really apply across a huge variety of different industries. So I'll just touch on different ones and let you think about how it might apply to the ones of interest to you. Jumping for a moment to the idea of a big drilling, maybe an oil drilling system. You have huge pumps, huge pieces of equipment, and if they fail, failure can be catastrophic. So using big data, collection of a lot of data, sensors, taking all kinds of parameters, pressure, vibration, or whatever, and you're watching it in real time, you can have dashboards, real-time dashboards that alert you to a problem. But if you actually combine that real-time sensor data coming in with some long-term histories, maintenance histories, and you develop some machine learning techniques to be able to look for patterns that might be an early pattern that would alert you to a potential failure. Maybe a pattern is something that you would see, an anomaly that happens weeks or even a month before things fall apart. You're able to go in and do predictive maintenance. And this not only lets you schedule maintenance more efficiently, it makes it more cost efficient, but it means you don't have a disaster and the problems from that disaster. So that's a very powerful use of these kinds of approaches. But you don't have to go to anything this sort of sexy or exotic as advanced manufacturing or what's happening in an oil field. Streaming really has become mainstream. People who didn't previously collect streaming data are beginning to do it now and see the value in it. And something as ubiquitous as looking at the clicks on a website, looking at clickstream data from visitors to a website, this could affect all different sorts of businesses, is really beginning to be done more and more. One of the things that drive people to this is usually the desire for real-time insights, perhaps something such as trying to update a real-time dashboard, and they want the sorts of insights. They build various applications using some of the wonderful new stream processing technologies that are available. But really it's what's upstream from that that can make a big difference in the overall architecture, or the stream-first architecture, and the value you get out of it. And so in this case, you might have logs, various kinds of data analysis coming in relative to activity in the website where you're looking for real-time analyses. But if you've chosen the right message transport technology, if you've chosen one of some that are available that have certain capabilities, this really makes you able to get a much broader range of value from streaming data. And so in this case, I use the examples, they're labeled ABC, just to think of different classes of how you want to use data, different users. If you have the right kind of transport, where you have persistence and you have durable messages. One thing you can do is sort of realize a state of the moment, look at what's happening. In this use case, it might be something like a customer 360 database, something that you're saving to a database, maybe to a searchable document. So you're seeing the world at the moment rather than the event-by-event history of how you got there. But again, if you have a long-term, replayable, accurate history of event-by-event, that gets us down to group C here, this kind of long-term history, which sometimes is very important if you have situations where you need to audit or go back and analyze what happened. Now this pattern, I've used the example of a web-based business, this pattern applies to a huge different range of businesses. You can imagine how the particular thing you're doing in each of those classes is a little different, but the overall idea is the same. So streaming data is enormously important for that real-time value of data, but it also has value beyond that, especially if you build the right kind of architecture. And that's one of the reasons as people realize this, that they're beginning to look at streaming data as being a more main part of what they do. It's moving into central parts of organizations, not specialized projects for particular real-time insights. So the point here is that you want to look at how you do that message transport. That's what's really at the heart of the system. I've switched aside to now be a medical example where you might have data coming in from various medical tests and equipment, but it's the same idea. So what do you need at the heart of the system as your message transport technology and the way you've designed the architecture to get this kind of range of value out of streaming data? One of the things I've already touched on for that stream transport system, you need something that has certain capabilities. These are some of the ones that we've identified. And really, in today's world, we find that Apache Kafka is a great example of technology that's really well designed. It fits this sort of modern architecture. It really delivers what's needed for doing stream transport. And MapR Streams, which is a very new technology, is part of the MapR Converged Data Platform. MapR Streams fills that same function. It uses the open source Apache Kafka API. It has a few capabilities beyond what Kafka does, but they're both well designed to meet this kind of stream-first architecture. And the reasons they're very good for this is that they have these key capabilities. I've already mentioned, obviously you have to have great performance. We're talking about huge volumes of data, things being done with very low latency. It's very important to have very good performance at scale in distributed systems. But the difference here is that you have to have great performance even while you have persistence. In some older message transports, that's usually a trade-off between persistence and performance. You sort of pick the tool or the technology for what matters for your system. But in these modern systems, you really need both, and Kafka and MapR Streams deliver that. You need to be able to support multiple data producers and multiple consumers, and they need to be decoupled. It's very, very important to have decoupling of the producers and consumers, and I'll talk a little bit more about that in just a second. Configurable time to live for message. In both cases, how long you keep a message from almost not at all to seconds, minutes, days, that's something that you decide in terms of how you want to use that data. So again, I think people are beginning to see that in some situations, there's an advantage to move away from the sort of use it and lose it approach to streaming data, where people who were looking for real-time insights pulled the data in, did analysis, didn't ever try to save it. Now there's some advantages to persisting that data. And again, we'll talk about over a whole range from short-term persistence to long-term persistence, depending on the use case, why that's an advantage in terms of this kind of architecture. Both MapR Streams and Kafka have that capability. MapR Streams also has the capability for very efficient geo-distributed replication. You can replicate a data stream, preserving the offsets, across data centers that are remote, and this can be done very efficiently. This is not important for all use cases, but there are many use cases in which this really opens up a large number of new opportunities. So it's a little bit of a specialized thing with MapR Streams. Now, going back to this idea of supporting multiple producers and consumers and being able to find a water bubble. To be able to support multiple producers and consumers, but to support those in a way that they are decoupled, that they're isolated. And what we mean by that is that the producers are delivering data to that message stream. The message streams makes the data available immediately to consumers, to multiple consumers, but the consumers don't have to be there at the time the data shows up. They don't have to be online. Indeed, you could add consumers, you could write a new consumer at some later date and add that into the system, and it doesn't have any effect on the consumers that are already using data. So this suddenly provides an enormous level of flexibility to a system. It's quite different than a message transport system where the message is coming into the transport from the producers and then it's being automatically broadcast to all consumers. So the message is there, use it when you need it, use it later if you need it. And that's a big difference. So high throughput, low latency, highly scalable, and this idea of durable messages allows you to have this kind of decoupled system. Otherwise, you wouldn't be able to do that. And in addition, if you're able to save those messages over very long history, that opens this idea of a long-term auditable log as an additional way that you might want to use the data. I put in this picture of a cup of cappuccino as a reminder to myself. And as it turns out, today, being November 4th, it actually reminds me of two things. So one thing it reminds me of is a year ago, it was November 3rd, not November 4th, I was in the Bay Area and met at a coffee shop with Kostas, who's down here in the front row. Raise your hand. Kostas is the CEO of Data Artisans. He's a committer in the Apache Flink project from day one, and he and I have written a short book on Flink. Kostas is going to do a talk on Apache Flink just after this talk, and he and I will be signing free copies of that little Apache Flink book at the MapR booth at 110. So it was 1 year ago that Kostas and I sat down at the coffee shop and started writing the book. And so a year later, now we have a book to give you. That's not why originally I put the picture of the coffee in the slide. For years, I love coffee, I love a cappuccino, but I have to drink coffee much weaker than most people do, mostly milk, a little bit of coffee. It sounds simple, but when I go to order one, I get all sorts of varieties of incredibly strong cappuccino in terms of me finally trying to order it by saying, give me a cup of foamy milk and give me 1 shot of espresso on the side. And so they give me a cup with a double shot of cappuccino, or espresso in the cup, and an extra shot on the side. And the reason this happens, I finally figured out, is that people are trying to be helpful, but they have such a strong preconception of how the world works and what a cappuccino is. I couldn't possibly have meant what I actually said, so I must have meant that I wanted extra coffee. And it got me thinking about the fact that there's a challenge in this whole business of big data revolution, of trying something innovative, of explaining it to your team, of explaining it to your customers, really understanding it yourself, because the more knowledgeable you are about working with certain types of data, the stronger your preconceptions are about how things work. And so you may miss out on one of the opportunities to use things in not just new things, but a new technology in a new way because you have a strong idea about how to do things. And where I've run into this in talking about message transport, and particularly talking about MapR streams, is that people who are already very familiar with working with streaming data, perhaps they've been using Kafka a lot, they just assume that MapR streams also runs on a separate cluster, as you would generally do with Kafka. But in the case of MapR, it's actually part of the converged data platform. Files, tables, streams are all part of the same system, the same technology. They all run on one cluster, and that's a foundation on which you run various open source tools, your custom apps, whatever you build. So you don't have that hop between data transport or message transport for streaming data and the system where data is stored, the system where you're doing the stream processing. It's all part of one. And in some cases, that's not a huge difference. In other cases, it really makes a big difference in terms of the design of systems. So whether it's this or any other aspect, any other sort of new technology, new innovation, is look inside yourself and make sure that you are looking at things in a very open way, and often you will find that you're better able to make use of the innovation than you might be otherwise. This is me trying to explain it to somebody. Okay. So back to looking at the details of how this message transport works. This little timer was great, but it just went off. So I think I'm going to speed up here. You've got producers, you've got consumers. Data is assigned to a topic. You can actually name that topic. Generally, the topic has partitions, which helps with load balancing. This is true for Kafka, it's true for MapR, it's all the same. In this case, the one small difference is that, big effect, is that the topic in MapR streams, because it's all part of that same platform, is actually distributed across the whole cluster. That topic partition, the partition, does not have to live on one machine. And where that actually begins to make a big difference is if you do want to use data as a long-term auditable log, it makes it quite reasonable with MapR streams to save years of data. The system can easily handle that. You probably wouldn't want to go to data quite that long in some of the other systems. But otherwise, they're functioning very similar in terms of partitions and topics. Using back to the example of pumps and sensor data on pumps, another difference with MapR streams is that you can have a very large number of topics and they're bundled together into a collection called a stream, confusingly called a stream. A MapR stream is a first-class object in the file system. This collection of topics at the stream level is where you apply policies such as access control, replication, this geo-distributed replication, time to live. So if you think of that in terms of our drilling example, now you have multiple pumps, different sensors on each pump might be assigned to a topic, each of those topics bundled together in a stream and handled in a certain way, but subscribers, the consumers subscribe to it in different ways. So maybe a real-time dashboard only needs data from one pump. The other group of consumers might be using data from all of the pumps. This decoupling of producers and consumers, this style of message transport, this style of architecture actually lets us support microservices. It's very, very powerful when you do this because, in this case, a fraud detector, by sending that data out to a message stream rather than directly updating a database, now the database becomes local knowledge, the stream becomes kind of the universal truth, shared knowledge, and that opens up the system for other people to be able to use that data, other systems to use that data in different ways. Very flexible system. We've talked about replication across data centers. There's an example here of replication in terms of container shipping, being able to actually have a cluster on a ship. You're picking up data from the containers as to the status of what's in those containers. You come into port, make a temporary link, copy that across to maybe an onshore cluster. The ship goes to the next port. Even before it gets there, that onshore cluster, perhaps in Tokyo, has copied ahead to Singapore. Meanwhile, the on-ship cluster is collecting new data. It comes into the next port and updates what's happening. And all of that might be sent back to someplace else, corporate headquarters. So there are use cases like this where that geo-distributed replication makes a big difference. Just touch on this. Another is in the case of ad tech industry, where the ads themselves are actually a shared inventory. You may need that across different data centers. This ability to replicate streams can make that really handy. I want to just touch on, and I'm not going to go into depth on this, there isn't time, and also Kostas is going to give a talk right after this about Apache Flink, and I recommend that you go to it. I think it'll be a great talk. But in terms of stream processing, there are a lot of good choices. There are a lot of good technologies. They are not all equal. If latency is an extreme need in your project, do keep in mind that Apache Spark Streaming has a micro batching process. You don't get those very low latencies. Storm, Apex, and Flink do. For many other projects, that kind of latency that you can get with micro batching is good enough for what you do, and it's a fine thing to do. MapR talk about a lot, so MapR actually ships with a full Spark stack, has a huge community around it. It's obviously very widely used. I've been talking about Flink because we've just done the book, so it's on my mind. Flink also has a huge open source community. It actually is true streaming. You can get real time. It's also good for batch, so it'll go right across the different latencies, and go and talk to Kostas or come get our little book to find out more about Flink. I remind you that Flink is big in Europe, even better known in Europe than the rest of the world, but that's changing fast. I want to end here, yes, I still have a few minutes, just kind of put this all together. So there's so many different use cases where these kinds of techniques have an advantage where they apply as one part of what you're doing. But let's focus in for a minute on telecom, which really is a big data wonderful example, but also for streaming, because the telecommunication systems need to use data in such a variety of different ways. I mean, they are a business. They're dealing with customers. They need to look at customer satisfaction. They're a technology. They need to be able to respond to things that's happening in real time. They often have multiple centers. There's have global issues. So it's a really complicated system, but it really shows off these kinds of techniques. I want to look at just one aspect, and that is for companies that are looking at customer satisfaction. This is important wherever. Again, I tend to look at MapR customers. I've been looking at people who are using Flink just recently. There are a lot of telecommunications customers in both of those examples, whether it's North America, Europe, Asia. I think particularly in Asia, this customer satisfaction issue is a little different because people tend to not have the long-term contracts. They have shorter-term contracts, and so churn is a real issue. People want to be very responsive to what's happening with customers there. So let's take an example. Customers are communicating back and forth with their handheld devices to different cell towers. Obviously, you want to distribute that. Some towers are getting more use than others, but it tends to be reasonably balanced for a system that's set up well, and you have pretty good service and good customer satisfaction. But what happens at a sporting event or some other event where you suddenly have a flash mob around one area? Maybe they're all trying to communicate, text, whatever, relative to that event, and you may overwhelm that tower. So in that situation, you want to be able to do tower tuning. Maybe you want to be able to use this tower to respond more to that crowd, and this other crowd can be picked up more by the other tower, so you want to actually tune it, and you need to do it fairly fast. So this has been a challenge as you have all of these different callers responding to towers. The towers, of course, are collecting the call record data. It's going back to central, not only to inform immediately what you're doing with the technology, where there's outages, how usage is, but to be able to keep records for billing. So it's fairly complicated, but you need to be able to respond to that fast. And it turns out that in these big systems, the data collection, handling, and even some of the processing happens at different levels. And I mean literally levels of what happens at the tower, some processing near the tower, intermediate data centers. A lot of it may be consolidated back to some larger data center, some headquarters, especially for doing the billing. And so at each of those jumps, if you're using a batch system, sometimes latency can be around 30 minutes. And so if you add that up, say you have 3 jumps, people are trying to listen to an event, that's a very long period of time to have less than stellar usage. You can imagine when people get that customer survey, they're not going to be that happy. If you change from batch to streaming in these systems, and if you have an efficient way to process that data, an efficient way to move it around, you can actually drop that latency to seconds or sub-seconds per level. Suddenly you're able to respond to events as they happen, and this makes a huge difference in customer experience. So this is just one issue that telecom faces, but I think it's one that really shows off some situations where streaming makes a huge difference over batch, or put in short, streaming data makes sense because life really doesn't happen in batches. So just to close, there was a book signing yesterday with this little streaming architecture book that I did with Ted Dunning, who's sitting here in the front row. There are copies of it available courtesy of MapR, that if you want to download a copy or just read it actively online at these links, and I think we'll make these slides available. Kostas and I will be signing this book at 1:10 this afternoon, so I hope you'll slide by the MapR booth. This is the first little book on Apache Flink. It gives you a basic idea of what Flink can do and how it might work in your use case. MapR also makes available a free resource on Apache Spark, which includes some information about Spark streaming, and that again is available for a free download PDF or to read it online. There are a variety of other books that I've written with Ted Dunning for O'Reilly. MapR makes those available for free. Please help support women in technology. Whenever I go to a big technical conference, I actually do want to see a line at the women's room, and then I have to correct this. I want at least 50% of those people to be women, because at one of the big conferences, the men's room was so full that they moved over to the women's room. Let's get more women in technology, please. Thank you very much for having me here.